invitation. I'm very happy to be here. I got it, sorry. Okay, so I'm very happy to be here. I'm Baptiste, so I'm a senior researcher in Paris. I'm also affiliated with the Sorbonne University, and I'm part of a very new group focused on HCI called HCI Sorbonne Group. And I will talk about interactivity in machine learning. I think it's a kind of a strange title for what I'm going to talk about, because I think I'm going to talk about something quite broad. But I guess everything will be kind of circled back to around this idea of interactivity, agency linked to machine learning. And yes, I'm going to talk quickly also about this special issue, but I have only one slide. So if you want to, if some of you are interested more in details about uncertainty and this special issue we published at UCLIC last year, I'm really happy. I mean, I will be around right after this talk. I'm happy to discuss. Yeah, so I would like to start with the, okay, with the slide. Yeah, let me try that. Yeah, okay. Yeah, machine learning is a timely topic, machine learning and artificial intelligence, obviously. This is a picture that is not meant to be read. It's just a kind of landscape that is actually 3 years old of machine learning, AI, and data landscape with a lot of companies that are dealing with this technology in very different sectors, infrastructures, analytics, finance, speech, name it. Why I put this? Because it's really to show, this is related to the application. It's really to show, if you don't know, that machine learning is very much ubiquitous, is very much pervasive, and it's, let's say, its integration in digital technology is growing. So one question that we can ask, I mean, regarding this kind of ubiquity of machine learning is how interactive machine learning based systems are, right? And actually, when I am teaching a class called Interactive Machine Learning to students, master level, and when I'm kind of asking them how interactive they find, or what's to them, what is the level of interactive of machine learning based system that they are using, and it's mostly kind of comes back to this idea of machine learning as a service, right? It's like we are users providing data that goes through either a smartphone, a computer, whatever, and then we get a prediction of something. So this is an example of PlantNet, which, if you don't know, it's an application that allows you to recognize plants based on either leaves or bark pictures. So same is true with the other type of machine learning based system or AI based system. There is very much this idea of machine learning as a service. And this is very much what the interactivity is nowadays. And I will try in this talk to kind of unpack this idea. Unpack this and try to maybe show you or present some research we have done with the students and colleagues, trying to provide more interactivity into machine learning based systems and trying to apply that in different types of domain. So first of all, I would like to present a bit more in details what are the different stages of machine learning based system development and usage. So right now, and conventionally, machine learning based systems are developed by experts, right? Who is able to, or she's able to write code, to understand accuracy, precision. And so this expert or this group of experts can have the agency or can choose the data set that the system can be trained on, the type of parameters, the models that the model is using, the type of metrics, and so on and so forth. So this is done in companies or eventually in some kind of in research labs, but mostly in companies. And once the model has been trained and has been assessed and say, okay, now it's performant enough. It's deployed and it's used by some users. So this is the user side. So typically, a user can be a domain expert, clinician, or lay people using PlantNet, or like a plant fan using PlantNet. And so this person, these users, what they have, they can have access to the ML system just through through providing data. And what they get is they get predictions. So it's a bit what I've mentioned previously. So this is kind of the kind of the state of the art, or like the conventional way to develop and use a machine learning based system. But this implies many problems, right? One of the problems with that is that if you choose to develop these systems independently on the usage, on the context it is going to be used, we have several problems. One of them is that these systems are actually black box, and they prevent system auditing. So basically, when users start to use them, they cannot really necessarily have the tools or the agency in order to be able to audit this type of system. Also, this opacity with this type of system and this type of development process hinders ML literacy, meaning that if you don't have access to the way, if you don't have interaction means to be able to explore the capacity of the system, you might not be able to understand it and to understand the technology that is behind. Also, another problem, which is the problem of bias, is when the system is basically, if a system is developed in isolation of its context of use, and so of all the sociological context in which the system will be integrated to, it's highly, it's likely that the system will be prone to harmful biases. And therefore, it will be less robust in deployment. And the last point I would like to stress is that if you choose to have this kind of approach, of the kind of process where systems are developed in isolation to this use, you have necessarily a centralization of power, which is power to the people who are actually building them in their context. So this is a state of the art. This is what's most of the machine learning system and AI system are actually following, the development cycle that the AI system are following. So what HCI research can say about that? So back 10 years ago, some researchers at Microsoft wrote this article called Power to the People, and it was the role of human in interactive machine learning. So it was 10 years ago, and what they proposed in this article, and I put the diagram here. This is mostly the diagram I showed before, where you have the expert in machine learning that is like interacting with the learning system, that has access to everything that constitute the design of this technology, and the user that doesn't have a lot of agency over the learning system. So they propose another approach, which is like something that connects directly the user to the machine learning system. And so in this case, the user has access to what? To everything: data, design parameters, choice of the model, and everything. And as feedback, the user has some predictions or recommendation, so a different type of metrics, but also visualization and so on, which should be adapted to the level of expertise of that user. So this is the interactive machine learning cycle. And they call it power to the people because the people have agency, have more interactivity on the machine learning system. So it was in 2014, and at that time, basically, the idea of machine learning, I mean, the question that was behind this is like, can interactive machine learning be a tool to help with, for instance, less well-defined tasks, and also create interesting experiences for the user? So they were not the first one investigating interactive machine learning. This paper is a kind of essay, is a kind of position paper about this approach. And so what they show, or what they report in this paper, is that what type of user interaction we can have. Is that what they show is like, okay, users are people, they are not oracles, meaning that they are not some people, they are not some provider of data, provider of labels only. Actually, there is another result here showing that people naturally want to provide more than just label to the system. They don't want just to annotate data, they want to do more. If you have some user interacting with reinforcement learning-based system, which are machine learning-based system using rewards and preferences in order to learn, they show that people tend to give more positive than negative rewards. And lastly, they show also that people want to demonstrate how a learner should behave. And again, this calls for something, for some more richer in modality, input modality than just labels and just data and labels. So all of this, what we can see here is that this idea of interactive machine learning is that very much like machine learning is very much like a tool to give a bit more of expressivity to the user. And again, what I said is that they are not the first one. There's like some kind of history of interactive machine learning research that you can find in the HCI community. And one of the application domain where this approach, where the user is actually interacting directly with the learning system. So one of the application domain that this system or this approach was really much, very much experimented and interested was in creative and artistic applications. And that's one of the domains where I've done quite a lot of research in the past 10 or 15 years. So why is that? It's because in this domain, you have a demands in exploration and personalization with people that they don't have necessarily the technical skills to, for instance, to program and to program the musical instrument or to program their system. Especially in musical interaction, these techniques or this approach of interactive machine learning has been widely used. I mean, we can understand why. It's because if we start to design musical instruments such as like body-based sensors and body-based musical instrument, it's very hard to program manually an instrument that will respond to gestures like this. I mean, you have like high-dimensional data coming in, and you have to control sound, which is also high-dimensional signals as output. And so what you can do basically, instead of saying, okay, I'm going to manually program that, is that I'm going to try to use machine learning, provide examples of what I want, like example of gesture and example of sound, and let the machine learning system learn the mapping between my gesture and the sound. And so that's part of the research that these people have done, and I'm part of them. I'm going to show you a very quick example of colleagues from IRCAM that demonstrate the idea of using machine learning as a way to design this type of musical interaction. So here, what you're going to see in this video is you will see a demonstration of a gesture that is made while listening to a sound. Then the system will learn the mapping, and then the user will perform with that sound. So it will start with the, there are environmental sounds. So the first sound is a sound of water drop. I don't have sound anymore. No, I think it's going out in the... Sorry, I'm gonna try again. No, it's coming out of my computer. Let's try. There was one demonstration, and now the system learns, and the user can improvise. So you can add other sounds, so other gesture. And you can explore the timbral vibration by just changing the gesture. So again, this is, if you want to do this manually, it's very hard. If you use machine learning, here is a regression model, it becomes pretty handy and quite useful to explore very quickly the possibility of the system. It can also work not necessarily with an input gesture, but also, this is another project led by Hugo Scurto, where we basically ask sound designer to find, well, like to design sounds, but based on preferences. So basically what they did is like through preferences, so saying, oh, I like the type of sound I'm listening now or not. The system will learn a path within the sound space. So it sounds like this. So the system explorer, this is to jump in the space. And the right say, no, no, I don't like it. This one. So the system will try to find another direction. And the green say, okay, I like this. So obviously, then you can go back and do several. There's several ways to adjust the system. You can also demonstrate with the parameters here. Say, okay, and demonstrate what I like, and from there you can start to explore. And so here is reinforcement learning behind. That's basically what is interesting is that it's not necessarily only marking a zone where the sound looks nice for a sound designer, is also highlighting a trajectory, how the sound changes. So in the different example I showed you, what I wanted to illustrate is that here the user has kind of full access on the ML system. They have access to the data, they have access, they could change the model, they have access on parameters and preferences. And as feedback, they got sound, okay? And so this allows really much exploration, performance, but also involve qualitative assessment. Here is very hard. I mean, you cannot necessarily use a quantitative assessment such as accuracy or recall or F-score, the kind of metrics that is used in machine learning in order to assess the ML system. Basically here, it's mostly a qualitative assessment performed by the user saying, okay, this I like, this corresponds to what I want. This is a quote from one of the sound designer that pretty expose it. It's like, I could use it because I feel empowered and more expressive with it. But of course, I mean, you might have in mind, say, yeah, okay, it looks interesting, but eventually this is possible because the ML system or the machine learning system that I've involved here, what I shown, they are not maybe the ML system we know nowadays. I mean, they are very small models, right? I mean, I didn't really give any details about it, but being able to train a system with one or two examples means that the model behind is really tiny. So yeah, this is really small data. It's really it's not a lot of demonstration, not a lot of examples. So it's models that have low capacity or limited capacity in terms of what they can learn, but still they are useful. They are useful in this type of applications because they allow for exploration and quick performance. So the next question is, how about interactive machine learning in the age of deep learning, which is maybe bigger models than the ones that are involved in the previous example. So when we consider higher capacity models, so like deep neural networks, I mean, I don't know how familiar you are with this type of technology, but let's say that there are models that are not able to classify just few gestures, but like thousands of classes. So they have the capacity to understand much better the input modality we give. There are gesture, images, sounds, whatever. So what I found interesting when we start to work with like deeper model in this context of interactive machine learning is the possibility to think about teaching these systems. And for this, I take this image from one of the article titled Interactive Machine Teaching by Gonzalo Ramos that exposed the idea pretty clearly. So the idea is that we have now a system that is higher capacity that can understand maybe higher, more complex concepts than just one gesture or two. So maybe let's focus less on the learner, but let's focus more on the teacher. So how we can basically leverage the teaching capacity of humans in terms of expliciting concept and transmitting concept in order to train machine learning or to fine-tune machine learning system. So if we focus now on the teacher and less on the learner, these are the phases that are interesting. There is the phase of explaining, how I can explain the concept to a machine. Again, the review, how I can review what are the feedback I can give in order for the user to understand what the system has learned. And everything about planning the teaching, so the curriculum. For instance, should I give this example first and this one? Should I start with simple concept and then getting to higher, more complex concept, and so on and so forth? And these are really interesting concepts that I feel that are still very much to be explored in terms of research. And in order to understand or to explore this, I would like to go back a bit to first the key concept. Sorry. So first, the key concept about the teaching, to machine teaching is that again, we have to leveraging on teaching ability, and this is important. Is that the data is not identically distributed anymore. And so the idea is less focus on universal model design. But what I wanted to say is like, in this case, again, looking at creative and artistic practice can actually be inspiring and can give us ideas about how to consider teaching or to consider interaction with deep learning in this case. And I would like to show you a video of this artist called Memo Acten. This is a video, this is a piece called Learning to See. And this video is like facing with the webcam. It's like facing with the webcam a generative adversarial network that is generating in real time what it sees. But it generated what it sees based on the previous image. So basically, all the previous image, all the feeds of the webcam is used as a way to train the system. So as soon as the artist starts to move too much, the system cannot understand it anymore. What I found really inspiring in this work is that the teaching process, the way that the artist is actually teaching the model, is actually exposed. I mean, the learning process is exposed. And actually, he developed that initially in order for him to understand how the model learns. So as a way for him to visualize the learning process of this GAN. And then this became an artwork per se. Another example from the art context that I would like to show you is this example by Anna Riedler. Again, in this idea of teaching, this high capacity model. In this work, what she did is she collected, actually, she curated a data set of photos of tulips that she used to train also a generative adversarial network. And she made two pieces out of it. So one piece is actually exposing the data set, which is this set of thousands of pictures. And the other artwork is actually the video, which is the generation of the output of the model. And what is interesting here is that why I show that is because if we start to think about teaching machines, it must be less about collecting as much data as we can. It's about curating data. It's about what makes sense in the data set in order then to be able to transfer a concept to a computational learning technique. And in the work of Anna Riedler, she actually has also some political stance about it. What she says, like, I actually think that a lot of parallels between craft and art and between data and model. I think there are a couple of things, like the relationship between craft, which is often anonymous and less well regarded because of its repetitive nature, and art. And when you see the datasets are anonymous, nobody talks about them, and they are out there, and people are using them. So she's also making the point that about curation of dataset that becomes also like a crafting work in this case. So go back to the teaching, machine teaching research direction. This is a work that we did with an ex-PhD student of mine, which is with Theo Sanchez. We kind of simplify the task and we say, okay, let's try to see how people that are novices, that are non-experts in machine learning, some of them were high school students, how do they teach a machine? So in this case, teaching machine means make the system recognize drawings. So we have several classes. So it's in French, but okay, this is actually recognize a hat. If you read French, is a chapeau. But we have like several classes like hat, moon, wave, cheese, time. And the goal is like people are actually drawing, they see what the system is recognizing, and they can change, they could correct the prediction, add it to the training set and train it straight away. So through this, you have also, again, in this, if you remember this interactive machine learning workflow, you have like a data set providing a data set, exploring the capacity, and going back to the training by editing the data set and retraining the model and so on and so forth. And so what we found in this research, which is a qualitative research, is that people use very diverse strategies and project a lot of thoughts and folk theory about how the model learn. We show that the data variability impacts results. Some people were trying to be really consistent in their drawing, and others like really explorative in their drawings. Most of the participants adopted curricula. They say, okay, I'm gonna start with something simple, and then I'm gonna augment the complexity of the data. And they have a lot of different interpretation of the model behavior. So what makes this real-time training possible is that we were using transfer learning, meaning that we were using a model that was like pre-trained, and we were just training one part of the model in order to basically fine-tune it on the specific task, which is this sketch recognition. If you're interested in that, there's this nice paper by Mishra at Kai 21 that build a whole toolkit exploring transfer learning with the non-ML expert. And so part of this work, as part of this work, in the video, there was like a whole thing about the uncertainty that we actually extended this work with Theo in another paper where we try to see how uncertainty can help people to teach a machine. If you give a good idea of the type of uncertainty that the model has, typically the uncertainty related to the novelty, so something that is not part of the data set, something that the model never saw, or an uncertainty about the ambiguity of the model, meaning that, okay, this drawing is between this class and this class, but I'm pretty uncertain what it is. So we use these different type of uncertainty to help people teaching. Recommend the reading of the paper if you're interested. But this led to this research direction where we really focus or really consider uncertainty as really critical in the design of machine learning models. And that's where this, part of this special issue came from. So that's my slide about this special issue. So if you want to, again, if you want to discuss more about this, we can talk about that. And something important that I wanted to mention here related to interactive machine learning related to higher capacity model is that we, as part of this endeavor, as part of this research, trying to explore the interactivity with machine learning, we developed a framework called Marcel. And so this framework is basically a way to develop interactive applications. It's a front-end development framework to compose or to develop interactive application with machine learning. Why it was critical to work on this tool is because actually this tool came from our teaching class, because at some points we were like, okay, we want to teach to students how to build or how to research, but how to build applications that are interactive. In interactive machine learning applications. And we couldn't find really any toolkit or framework that help us to do that very quickly. I mean, there's a lot of Python framework if you want to do machine learning. There's few things in the creative application. There's the Wikinator made by Rebecca Fibring, for instance, more rated for gesture-to-sound music. But if you want to build highly interactive application with machine learning, it was pretty. There was not the tool, so we started to develop Marcel, and we are still on it. That's a long-term process. And I wanted to give you a demo of that for you to understand a bit more what it is. Okay. So this is the website. What I show you is a really quick demo about what it means to code and to do some to code in Marcel. So this is my app, and this is my code. So you don't necessarily need to fully understand JavaScript. Don't worry. Okay. This is pretty much the code of this app here that does nothing. There is just one component. Welcome to Marcel, and this is my code. You can see that welcome to Marcel is here. The dashboard is basically my thing, all the dashboard here. There's a page called welcome, which is this one. Okay. And so what I'm gonna do, I will copy paste the code of a demo, which is the sketch-based recognition system, and show you how it works in live. So if you go to the website, there's a guide with a getting started. There's a lot of demos. You can have a look. So if I'm copy pasting this piece of code, which is like 60 lines of code, so I'm just put my app here. Okay. So since I have a huge screen, I can see two things at the same time. Oops. Okay. Sure. I'm stuck. Okay, it's here. Okay, so if I'm saving this, okay, this is my application. So it's kind of updating automatically. It's a bit magical, maybe like this, but basically what you can see is just everything that is here. Basically my sketchpad is this thing here where I can draw my super drawing. So what I can do here is, like, for instance, draw a house, record. Well, I need a few examples to train my, this is exactly the same system that I show you in the previous project, Theo's project. This is a really badly drawn car. Don't judge my drawing skills. Up. I'm pretty consistent. Up. Okay. So then I can train my system. Oh, wow, accuracy 1. And I can have like direct evaluation. Okay, I can start with the cube. It's a house. But if I'm starting to maybe to add wheels, maybe it's a car. Okay, it's a car. Yes. And since the idea of interactive machine learning is like, okay, I can readjust maybe the way I'm drawing house. I'm gonna try to confuse the system. Yep. And so on and so forth. But what I wanted to show you is that what we did, Marcel, is really based on this idea of different components that you can adjust, that you can compose in order to make your interactive machine learning app. And if I say, okay, now, but we try to really differentiate what are the data, the model from the modality and the interface. You could say, okay, now I don't want to sketchpad anymore, but I would like to have a webcam instead. So if I'm saving this, now I have a webcam. Okay. Okay, this is me. And I can add it to the, okay. So I can train a model that does something with that. Doesn't mean, I mean, that's doesn't mean anything in terms of machine learning, but just to show you that very quickly you can have something that works. And same direct evaluation. Well, obviously it cannot recognize a car. Or maybe if I have like a pen and a white paper, I could draw a car and put in front here and it might work. And if you don't want to look at your data this way, you can maybe, instead of the data browser here, which is this component here, you can say, okay, now instead I'm going to use the data set table, which is another way to visualize data. And you have your data set table. It doesn't change anything the way your application work. It just changes the visualization. Okay. And so this system is quite handy because it's very useful for us as HCR researcher trying to investigate this idea of interactivity in machine learning, machine teaching, and so on, because it allows us to do this application very quickly, log data. But also, it's not meant to do only demos like this. It's meant to be collaborative. So basically, since you have, this is me as one user, but you can build another interface for another type of user, maybe with lower skill or higher skill in machine learning. But everybody sharing the same data, same model, but with different type of interfaces and different type of interaction means with the model. So for a machine learning expert, maybe you will keep these things that you are here, which is the loss curve and the accuracy curve. If you have done a bit of deep learning, you know what it means. But maybe if I'm talking with someone that is actually a novice, you don't care about this, maybe you will use another way to visualize the data, maybe using the browser I was using before, and other type of visualization. But still, the two users can basically work together and collaborate on the same model and the same data set. And that's very important. And we have few projects in collaborative machine teaching, for instance. Okay, that was a very quick demo of Marcel. And again, I'm happy to tell you more about it. So the last, very last thing I would like to show you or to present is in 5 minutes. Is okay. Coming back to Amersh's paper about power to the people. Interactive machine learning as a way to give power to the people. What we have seen in our research, but also instead of this, like interactive machine learning can indeed empower people with specific needs. So we have also some projects in processes control, for instance, that I didn't show, or people with no necessarily technical skills, like some artists with who we worked. But also, but the problem, okay, it can empower people, but what we saw also is that machine learning understanding remains a really hard challenge. So it can be at the individual level, a user interacting directly with the model, but also collaboratively when several people are trying actually to teach or to build a model together. So there, it's still a very much a challenge. And we can ask actually who are the people in this title, and most of the cases here they are single users that are using these systems. And again, they don't have necessarily technical skills, but they have a literacy. They have digital literacy, the people that that paper is talking about, and that our research is also dealing with. So can interactive machine learning be scaled up in a sense that can it be something, can we give more interactivity and more agency to a larger set of people? And with not only with the deep learning or like the tiny models, but also deep learning, but also the large language model, for instance, or the large models that we know today. And that's a very much an open question that we are looking at. One bad example of AML at scale, it's this example by, I don't know if you know this thing. It's already a few years ago, but it's Microsoft that puts online this tweets, like a teenager that you can discuss with, and she's learning because they personify this Twitter account as a girl. So you talk with her, and she's learning through your discussion, and you can teach her things, and she will discuss with you. And after 24 hours, she became, Hitler-loving sex robot. So that's a bad example of AML at scale. There are several challenges, obviously. Some of them are very technical to do AML at scale. Nowadays, the models are very large. They are not the tiny models I showed at the beginning, even though they are not the transfer learning model that I've showed after. There are billions of parameters, so it's very complicated. You need very large data set. And you need access to computing infrastructure that are not given to anybody. Then more socio-technical challenges that the speed of innovation in this field is so high that it's very hard to cope with that. And maybe your model will be, your system, your AML process won't be very compatible with the next model. It's very hard to cope with. And the fact that the process is very opaque is kind of hard to right now to understand how actually to do that. I mean, before, even with deep learning, you have a lot of code online on GitHub that you can just download, run on your computer, or, okay, 1 GPU, 2 GPUs. And right now, it's impossible because it's very even hard to know what are the, I mean, there are really few actually fully open large language or large models in general. And more cultural facts or cultural problems and challenges that even in terms of interaction with the system, there is a lot of hype over facts. And there are a lot of cultural lobbies that's kind of provide or give an image of what the system, what this technology is actually capable of. And it's very much harder for designers to know what can I do with that, because there's a lot of things that is said that this system are able to, but in practice, it's not necessarily true, or we don't know. And I would like to show this tweets by I mean, it's not tweet because on Blue Sky, but by Kate Crawford, you might know, because there was like this AI summit in France this week, and actually the end of next week, and the end of last week. So this AI summit gathering a lot of people from politics and the economical sectors. And what she said, and what she reported is like this gap between people very much into AI, very pro AI, who want pure expansion, more capital, energy, private infrastructure, and no guardrail. And on the other side, the public interest, which supports sustainability, labor, oversight, safety. And so interactivity and agency over this system. And so right now we are in a moment where actually these two things are pretty, yeah, the gap never looked wider. Okay. So one approach is like to go towards participation, and so trying to think about maybe interactive machine learning and AI more from the lens of participation. And funny enough, there was like another paper called Power to the People recently, 2 years ago. And this case was really about participatory AI, but again, it's like how we can give back agency to the user, or to the people in this case, because they are not talking about user here. And by participatory, they mean something that respects certain standards, such as reciprocity, reflexivity, and empowerment. So I just invite you to read this paper if you're interested in this. And also this article who is trying to do a state-of-the-art literature review of participatory machine learning and participatory AI studies according to this Einstein's typology, from manipulation, where there is non-participation, to a citizen control. It's very interesting to see how many studies you have along this ladder. Okay, and if you are also at the individual level, also we have currently a project that's look at this idea of regaining power over machine learning and AI. And this project is really about trying to think about shaping the AI development and modifying or trying to discuss the dominant narratives. It's very much centered on creative work and artists. Why? Because they provide usually another perspective on the cultural dimension of technology that, at least sometimes in our own field of HCI and machine learning, we are actually missing. So we just released a paper here early this year about the analysis of dominant narratives of generative AI and creative work with the people from Microsoft Research, part of who there was Kate Crawford, Ginny Williams, Gonzalo Amnos, and Vera Liao. Okay, conclusion, and I'm sorry, I think I took more time than expected. I guess my point with this along this presentation is that interactivity with machine learning bring agency to users, but there is still a lot of research needed in what it means in terms of mental models, the presentation that people have of machine learning systems, and how we can better understand all these teaching or testing strategies. We have to question the fact that if we really need a universal model in machine learning, and maybe not, maybe sometimes, and as I try to illustrate in creative application, we can definitely leverage small data, fast training and inference, and personalization and decentralization. So maybe we don't need one model, but we just need a lot of different models that will be much more stack specific. And I think when I wanted to also to stress here is that interactivity in machine learning is very much right now a power struggle, because this technology is becoming so captured by the political sphere, the economical sphere, and so technological innovation in machine learning and AI tends to limit interactivity, and this is a design choice, and so there is a need for fostering participation and actually being maybe activist in that sense to reclaim power over this technology. And I would like to thank you for your attention.